Welcome back to another question. So in this video, we're going to solve this equation here. Looks a bit scary, looks a bit like a complicated equation to solve, but fear not. Fear not. This is actually just a quadratic in disguise. To make this look more like a quadratic, I'm going to make a substitution. So I'm going to say, let y equal 2 to the power of x. If I do that, let's just have a look at what y squared would be. Y squared is going to be 2 to the power of x squared, and using my index law, I can multiply the powers, which becomes 2 to the power of 2x. So now I can make all the substitutions needed. So, rather than writing 2 to the power of 2x, I can now say y squared, and I can put plus 7y, replacing 2 to the power of x with y, minus 18 equals 0. Then, I need two numbers that multiply to give minus 18, but add to give 9. Or in my factorization, that's plus 9 and minus 2. Okay, equals 0. Then, from here, I have that y is equal to minus 9, or y is equal to 2. But remember, it's not y that we're trying to solve for, it's x that we're trying to solve for. So this means, therefore, instead of saying y, I can say 2 to the power of x equals minus 9, or 2 to the power of x is equal to 2. The bit on the left-hand side is like nonsense, so let's just, because you can't have 2 to the power of something equals minus 9, it's not going to work. If I were to try and say take logs of both sides, then what would end up happening is x would be log to the base 2 of minus 9, but how am I getting to a negative number from 2? Not happening. So it's just this one where we can quite clearly see that x is equal to 1. Okay. The next question I want to solve goes like this. 2e to the power of 2x minus 13e to the power of x plus 15 equals 0. All right. So again, it's another quadratic in disguise. If I let y this time equal e to the x, that means that y squared would equal e to the x squared, multiplying the powers, that gives me e to the power of 2x. So I end up with 2y squared minus 13y plus 15 equals 0. I've now got a quadratic which I want to factorize. I'm going to factorize it using my hack. I will attach a link or whatever in the video so that you guys can get access to that hack, but you can factorize it however you want. So I'm going to do 2 times 15, which is 30, and I need two numbers that multiply to give 30, but add to give minus 13. So that's going to be minus 10 and minus 3. So that's 2y minus 10 in the bracket, 2y minus 3, all divided by 2 to give me 0. And then I can divide the left bracket by 2, giving me y minus 5 times 2y minus 3. Again, guys, I think this hack is so much better than the other methods that are out there. I will attach a link to this somehow, and you guys can get access to that hack. So that means that y is equal to 5 or y is equal to 3 over 2. But it's not y that we're interested in, it's x. X is the thing that we're interested in. So let me just separate this. So instead of saying y equals 5, I'm going to say e to the x equals 5. Or e to the x is equal to 3 over 2. So for this one, if e to the x is equal to 5, that means that log to the base e of 5 is equal to x. And for the other one, log to the base e of 3 over 2 is equal to x. I'm writing that just so that it's clear to see what the base is, but the logarithm there exists as natural log or ln or ln, however you guys want to pronounce it, is equal to x, or ln is equal to x over here. Those are exact answers, and just to use the calculator, if I wanted to say have some sort of approximate value, that's 1.609 to 3 decimal places, or what's the other one going to be? None of 3 over 2. That is 0.405, again to 3 decimal places. That's it, guys. It looks hard, but it really wasn't. It was just a quadratic equation in disguise. There we have it.